All right, welcome to Daily Math Concepts. Today, what we want to look at is a continuation on coordinate geometry. I have promised my student that I'm going to upload this video here that will respond to a question that we were doing in class. Students from 11 Hearts, here are the solutions for the question that we were looking at. It reads, a straight line passes through 2 points, A, which is 2, 3, and B, which is 3, 8. Determine, number 1, the gradient of the line AB. Number 2, the length of the line AB. 3, the coordinate of the midpoint of AB. 4, the equation of the line M parallel to AB and passes through the point 0, 1. All right, good. And the fifth question, the equation of a line Q, which is perpendicular to the line AB and passes through the point 5, 5. All right, so we're going to take our time and work these questions through. All right, so here it is. So let us look at first thing that we want to do when we're looking at coordinate geometry is that we want to quickly label our points, right? We could label our points. For example, all right, we could call this X1, call this Y1. We could call this X2. We could call that Y2 as well. All right, so what is our gradient? Remember, gradient, there's a formula for a gradient. Let us say we classify the gradient as M. The gradient is equal to Y2 minus Y1 over X2 minus X1. All right, remember, this part deals with the rise, and this part deals with the run, vertical, horizontal. So let us do some quick substitution. Y2, as you can see here, that's 8. So we're having 8 minus Y1, which is 3, all over X2, which is 3, minus X1, which is 2. And we're looking at 8 minus 3, that's 5. Over 1, which is just 5. So we're looking at the fact that the gradient is 5. All right, so we could put that beside that. So if you have 5, you're fine. 5 over 1 or 5, that's good. All right. All right, good. So that's the gradient. Let's look on the length of AB. Now we want to find the length of AB. In finding the length of AB, the formula for that is, and then you have to memorize your formula because you don't get these formulas from CXC. All right, so we're looking at the difference between X2, so X2 minus X1, and we're going to square that, Y2 minus Y1, and we're going to square that because we're utilizing the Pythagoras theory as we go along here. All right, let's zoom out a little bit to get some more space. So what are we looking at now? We're looking at the same labeling here. X2, 3, minus X1, 2. And we're going to be squaring that, plus Y2, 8, minus Y1, 3. And we're going to be squaring that. And then to find the answer, you have to take the square root of all of that. All right, let's see what we have. So this is 1 square, 5 square, take the square root of all of that. So we're looking at the square root of 1 plus 25, which is equal to the square root of 26. And the square root of 26 is, to 1 dp, we could say 5.1. All right, so we're looking at 5.1 units. Very good. So this would have been the length of the line AB. All right. Now, in response to the midpoint. All right. So the midpoint now, in finding the midpoint, the coordinate of the midpoint. So I'm just gonna write the midpoint coordinate. All right. So the midpoint coordinate is a formula x1 plus x2 over 2. That's going to give us the x coordinate. and then it's y1 plus y2 over 2, and that's going to give us the y coordinate. So let's look back at our labeling. We have to look back at our labeling. So what are we looking at? 3 plus 2 over 2, and we're looking at 8 plus 3 over 2 over 2, and then we bracket off that because it's a coordinate, so we're looking at 5 over 2 right there, and 11 over 2. Some people might write 2.5 and 5.5. That's fine. Any of these will do for the coordinate of the midpoint. Any one of these two ideas that you have is good and okay. All right, so we're pushing forward now. We're at the section where we're looking at number 4, which is the equation of a line parallel to AB. Remember that when two lines are parallel, like when two lines are parallel, say if this is A and this is B, and it's parallel to another line we call M, they are equal in distances apart, which means that they share the same gradient. They share the same slope. So these two lines, right, the gradient of this one was 5, which means that the gradient of M is also 5 because they are parallel. So when lines are parallel, they do share the same gradient. So in response to that question, we want to know what point did it actually passes through. So it actually passes through 0, 1. So we're going to be using the gradient of 5 and 0, 1. Now we're looking at the fourth question. We're writing the equation of line M, I should say, the equation of line M. Now we found out that the gradient of line M is 5 because it's parallel. So then the point that it passes through was 0, 1. So when we know the gradient and a point, we can easily from there navigate and move on. We're going to call this x1. We can call that y1 for this context. Remember, we could use the point slope form. So the point slope form suggests that y minus y1 is equal to m parentheses x minus x1. What we're going to do is to substitute these ideas that we have here. We're going to substitute them. These ideas, we're going to substitute them in the point slope form. So let's go. Y minus y1, which is a 1, which is equal to m, which is 5, x minus x1, which is a 0. So there it is. We have just substituted. Then we're just going to carry out our mission. Y minus 1 is equal to, we want to distribute the 5 inside, but definitely it's going to be 5x, and then 5 times 0 is 0. So we're not going to put minus 0. So it's just 0. So there's nothing around there. In order to finish this, what we want to do is to basically get the y to be by itself. So there is a negative 1 here. So we're going to be adding 1 and balancing the equation by adding 1. So at the end of the day, y is equal to 5x plus 1. And this is the equation of the line M. All right, let's see the last question. So the last question is right here. So the last question says that we want to determine the equation of a line Q, which is perpendicular to the line AB and passes through the point 5, 5. So now it's a perpendicular line. So let us see what's going on. Now, equation of Q. So we're looking at question 5, and this is the equation of the line Q. Now, what we know that it is perpendicular. It is perpendicular. So if this is AB, it's perpendicular. It's going to come like that. Perpendicular means it meets at right angle. So this is our line A, B, and this is the line Q. So perpendicular, So when one gradient, so if we know that this gradient is 5, which means 5/1, it means that the gradient for Q is going to be the negative reciprocal. So when you reciprocate something, you're going to turn it upside down, flip it. So 5/1 becomes 1/5. It's the inverse. And then you put a negative here because it's the negative reciprocal. So this is the gradient for the line Q. So right now we know the gradient is equal to -1/5. And how we knew that was because when lines are perpendicular, one gradient is the negative reciprocal of the other gradient. The point it passes through was 5, 5. So we could label this x1, y1 for this context. Still, we can use the point slope form. Y minus y1 is equal to m, open bracket, x minus x1. We're going to substitute now. Y minus y1, which is 5, which is equal to m, which is -1/5, open bracket, x minus x1, which is still 5. Now, as you could see, what we want to do is to distribute this -1/5 inside here. We want to do some distribution. So what we want to do is write back our y minus 5 right now. So this is y minus 5. We're going to distribute this -1/5 inside the bracket. So in doing so, we'll have -1/5 with x. And then when -1/5 multiplied by -5, we'll have this. Negative and a negative becomes a positive. So negative and negative becomes a positive here. So we'll have a positive here definitely because of the two negative that will clash. So it's 1/5 times this. So we are seeing where we are getting a 1 at the end there. If you're just wondering how we get the positive, let me show you again. -1/5 multiplied by -5. A negative and a negative becomes a positive. So 5 cancel itself here. -1 times -1, we end up with 1. So it's a positive 1. Hence, we have this positive right there. Now let's write y minus 5 is equal to -1/5 with an x plus 1. Because here we have 1 times 1 is 1. To get rid of that -5, we add 5 to both sides. The equation of the line Q is y equal to -1/5 x plus 6. So there it is, guys. Here it is. That's the solution to the questions. All right. Continue to watch Daily Math Concepts and subscribe, like, and drop a comment below. Bye-bye.